Understand about the question 2300 success pairs of spells and quotients. You are given two positive integer arrays, spells and quotients, which are of length n and m respectively, where spells I represents the strength of I, of spells, and position I represents the strength of jth position. You are also given an integer success. A spell and quotient pair is considered successful if the product of the strength is at least success. It says that if when we multiply the elements in spells and position each other, it need to be greater than or equal to success. Only then it is called as successful. And we need to return an array of length spells where if it shows number of portions are giving success as the result. For this, we have one of the brute force approach, and we are going to see it now. See here, it is so simple that we just need to multiply each and every element in the spells with the quotient so that we can find which is a successful phase. Seeing this example for zeroth element in spells, 5 is multiplied by each element in the quotients 1, 2, 3, 4, 5, and we are getting these as the result. And if we compare it with success, these are the elements which are greater than or equal to 7. So we return in the array as zeroth spell has 4 successful pairs. Similarly, we do it for the other two also. This is the brute force approach actually explained in this example. Now let's understand how brute force approach is done. Getting into the brute force approach is consisting of two simple for loops. We are having length as n and m of two different arrays, spells and portions. And also we are having, ignore the statement, sorry. We have taken an answer array so that we can return it in the output. And we are having a for loop for the outer array, which is spells, and it is running up to nth position. And similarly, we are having another for loop, which is running up to nth position, which is the size of the portions. And we'll be having count 0 initially for the every array we will be multiplying, and we'll be checking if the spells of high position and portions of jth position multiplied is greater than or equal to success. Only then we will be increasing the count, and after completing all the iterations from spells to all the iterations from quotients, we'll be adding the count to the answer array. And at final, when we are complete with all the spells, uh, we'll be returning the answer.
And the method 2 with the binary method so that the time complexity will be less than n square, sorry, mn. Coming to the code, we are having length of spells and length of portions as n and m, similarly as the previous method, which is brute force. And now the thing we are doing is sorting the portions array. The thing we are doing is to decrease the number of times we traverse the whole array of the portions, because for example, if we take a portions array of 588, here actually given is 858, this will be sorted and 588 will become. Now if we go to the mid element and if it satisfies the success, then it is confirmed that all the left array part will be satisfying the condition of success, and so the pair will be successful. So we can just ignore the left part and go with the right part. So this is the thing what we are doing so that we can avoid multiple times of traversal and calculations of the product. Coming to the code, here we are taking answer array as similar, and now outer for loop which traverses through the spells 3 to 1 here, and we have sorted now here 588. Coming to binary traversal, we'll be having two variables, left and right. Here at the beginning, left is 0 and right is 6. we can have two formulas, left plus right by 2 for finding the mid, or left plus right minus left by 2. We can use any of the formula which we are comfortable with. And coming to the product, we have taken here product in the long data type, since we are having the constraints to 10 to the power of 5. So to make it in the range, we are using long as the data type, and we are applying the condition product is greater than or equals to success, then we will be changing right equals to mid minus 1. It means, for example, if it's satisfied the mid element, assume this is the mid element for this, and if it is satisfied the success, then we need not to check this all, we just need to check the right part. So what happens, the right sorry sorry reverse I said, we need not to check for these all, and we only need to check for these elements. So the right becomes mid minus 1. So we will only be checking for these two elements, because as these are all greater than the mid, and where mid satisfy the success condition, so we need not to check to about all the right part. So we are only checking the left part. If it is not, if it is failed, then we will also check the left side. This is the else condition, and we'll be adding number of times. And see here, if the last left calculated is at 8, and then all the elements which are at the right of it will be satisfying the current success pair. So we'll be having this as m minus left, and after whole iteration of the spells is completed, we'll be returning the answer.